Now let's talk about decision trees. In the past, candidates were asked to draw decision trees on paper. But with computer-based exams, no drawings are going to be asked. Rather, it could be drawn for you and you have to interpret it. I'm going to use a simple question here, which I picked from one of the content providers for the ACCA. Captain Co runs its business through a number of centers. One of its centers is suffering from declining sales, and management has a range of options to do A or B or C. We use decision trees to solve complex problems. Problems where you are saying, if I do this, it will be followed by this outcome. Sometimes not only one outcome, but multiple outcomes. You want to put all this into one place and draw a tree to reflect all of them and evaluate the tree. Like I said already, in a computer-based exams, you will not be asked to draw a decision tree. So here are the decisions. Should we shut down the site that is suffering from declining sales and sell it for 5 million? So decision is shut down, outcome, get 5 million. Or 2, should we undertake a major refurbishment? That's a decision. That decision has a cost, $4 million. Or decision, undertake a cheaper refurbishment that has a cost, $2 million. Probability, 2/3 of any refurbishment have achieved good results, and the other 1/3 have been less successful, achieving poor results. So whether you do a major refurbishment or a cheaper refurbishment, there are 2 outcomes for each one of them. Good results, poor results. Good results have got numbers associated with them. You get 13.5 million if it was a major refurbishment, or 8.5 million only if it was a cheaper refurbishment. Of course, if you do cheaper things, normally you get cheaper results. It's as simple as that. Or we should do or the major refurbishment, cheaper refurbishment could result in poor results, could bring about poor results that will give us this or that. These numbers are all put together in a tree. You can understand why it's called a tree. Branches all around it. So a decision tree starts with a decision, a square node. All the branches around the tree are telling you the decisions, the choices you have to make. Sell it off and get 5 million. Or do a more expensive refurbishment that will cost you 4,000. The second node represent outcomes of the decision. O for outcomes. So if you do expensive refurbishment, the outcomes are good result or poor result. The probabilities are written as fractions there. The numbers that come are given to you. If you do a cheaper refurbishment that costs you 2,000, the outcomes are this or that. Some trees are more complex. One decision might come up with 3 or 4 outcomes, and you can imagine the number of branches that are drawn around it. You will be called upon to evaluate the decision tree, which is drawn from left to right. So the evaluation will be from right back to left, to come to a conclusion which is the best decision management should take. What we shall do is to start from left to right. You see what? If you sell it off, there's only one thing that will happen. You get 5 million, full stop. But the point where there are outcomes, which may result in this or that, at point B, we've got to calculate the long run average, which we call expected value. Probability of 2/3 times 13.5. That's P times X. Plus probability of 1/3 times 6.5. So if you do an expensive refurbishment whose results are good or poor outcomes, the average of those good or poor outcomes is 11 million. So all figures in thousands, $11,167. But if you do a cheaper refurbishment at point C, the long run average, which we call expected value, your guess is as right as mine. I'll repeat the process, is 2/3 of 8.5 plus 1/3 of 4,000, giving me average of 7,000. Going backwards, I'll say that, okay, decision to sell off, only one thing happens. We will get 5,000. Decision to do expensive refurb, we'll get long run average profit at point B, calculated above, of 11,167, but it will cost us 4,000 to do. Everything we do that gives us benefit costs us money in the first place anyway. It will cost us 4,000 to do. That will return 7,167 as the net benefit for us. Decision to do cheap refurb at point C gives us long run average profit calculated above of 7,000. But to get that, it will cost us 2,000 to do. We get a net benefit of that. So you see what? If you choose cheap refurb, the final result for you is a $5,000 net benefit. If you choose expensive refurb, the net benefit to you is 7,167, all figures in thousands of dollars. If you take a decision to sell off the facility, you get 5,000. As your benefit. Of all these three benefits, 7,167 is the best. So our decision is do not sell it off, do not do a cheap refurbishment, undertake an expensive refurb. So that happens to be expensive refurb is here. There was one past exam question repeated in the specimen exams, and I'm going to show that to you when I'm sending the notes to you. The candidate was supposed to just move the cursor and click on any part of the line, the tree, for expensive refurb and score the point. That is the decision to make. So complex decisions are put on a decision tree like this. Let's check out and come back. If you have any question you ask, then we can proceed on that.